Today we're looking at parts of similar triangles. This is section 7.3, and we're gonna need scissors today. I don't have them out, they're in the the brown filing cabinet on the back of the room, the one with the flowers. You can pause the video to get caught up at any time. So we're gonna first start off by cutting at the dotted lines. By the way, I hope you guys are doing well. Thank you for doing your part and being respectful and kind. I really do appreciate you guys. Wish I was there. Alright, so what I want you to do is find the one that says proportional parts, and you're going to place that on the table first. Facing this way. And what you want to do is put this one on top of it, and you will need to lower it a little bit further down than the line, otherwise it won't fold correctly. Okay, so don't forget, right above this line, you're going to fold it over. So you're going to fold it over like right here. You're going to fold it back. You grab both pieces of paper, make sure that they're lined up, and you fold back, so that you can have the property perimeters line up right in front of it. So look, I'm bringing it to like this, and then you'll just staple it at the very top. Okay, so you probably know by now that I'll be out for a few days. We are still going to be held responsible for this information. You're welcome to email me. I will plan to have a Zoom meeting with y'all soon, so y'all can ask me any questions before we get too far ahead with this material. When I come back, we should be having a test, so please do the best you can, help each other out, and you can always have volunteers to step up and do the problems together. If as a class you can't do a problem, please feel free to email me. I just need one person from the class to email me. If more people would like to take that responsibility, please do so I can get that question answered for you on the next video that's coming up. All right, so let's take a look. Parts of similar triangles. Let's flip this up. And when it says similar triangles have proportional segments, including altitudes, to remind you of an altitude is sort of like saying the height of the triangle. And what happens is that you start from the corner of the triangle and you go straight down at 90 degrees. So I'm going to put my ruler here. And go straight down at 90 degrees. And that's an altitude. You remember, like in the mountain, you say how high is the altitude of the mountain. Angle bisectors, we're really talking about angle bisectors here. And what an angle bisector does is cut an angle so both parts are equal. These do not have to be equal, but the angle ends up being equal. It's kind of cool how this one does it, and the proof of how these parts are proportional is kind of hard, so I would want you to take my word for it. If you're still interested on how this works, how these two parts are still proportional with an angle bisector, I can email you a link to a video that has a very good explanation. Alright, and then medians, what medians were is when you had to cut the segment in half. So here, let's call this the middle. Well, let's make it closer to the middle. And it cuts this section in half. From here, we go to the vertex, the opposite vertex. And it doesn't necessarily have to be 90 degrees. So it looks like it is, but it doesn't have to be. So all of these would still make proportional parts, and we'll talk about them in just a little bit. But let's do some examples. A A proportion can be made from triangles. Side ratios set equal to the perimeter. So first, we're looking at the perimeter. What does the perimeter mean? We're adding all the sides together. Just like last time we had the sides, there are ratios, the ones that you compare. On this one, we're going to compare 20 and 5. So remember, I kept telling you to write the first one you see first or from the left. So 20 divided by 5 is what we're going to write. I'm going to write on here that this was the sides of the ratio of the sides. And it will be the same. It will be equal to the ratio of the perimeters. You know, I wish I had an account and was an editor and have beautiful videos for you, but hey, I'm doing the best I can. The first perimeter, we don't know because we don't have this length and we don't have this length. So I keep telling you to write from left to right. This one's the first triangle that we see. And then this altitude actually doesn't matter for this problem, but it's still on there. We don't know the perimeter, so we're going to call it X. On this one, we do have the perimeter, so we have to do 5 plus 6 plus 8, and that gives you, gotta check my math here, $19. We're going to cross multiply. 20 times 19 is 380. And that equals 5x because we have to multiply 5 times x. We're going to divide by 5 to both sides. X is equal to 75. What does that mean? That means that the perimeter of triangle ABC is 75. Let's try that again. So we're looking for parts that correspond to set the ratio. It's easiest if we set up the sides first. And this one doesn't have a number that corresponds on the DE, so we're not going to select that one. AC does not have a number that corresponds with a DF, so we're not going to write that one. That means the ratio of the sides that we're going to do is these two. So we're going to write 32 divided by 6. And that's equal to, and now we got to do perimeters. So the ratio of the sides is the same thing as the ratio of the perimeters. Now we got to do 30 plus 32 plus 40 is equal to 102. Since it was on the left, or it gave it to us first, then that's why we write it on the top. That's your numerator. And then your denominator, we don't know. We don't have enough information, so we call it x. Now we're going to solve for x. We cross multiply. 32x is equal to 612. Divide by 32 to both sides. X is equal to 19.25. What does that mean? That means that the perimeter of the triangle DEF is 19.25. Let's take a look at the next one. All right, on the next one, we're going to set up all of these proportions kind of the same. These are still set proportional to each other, and we want corresponding sides, so this one corresponds with this one. We write 20 divided by 5 is equal to, and then the altitudes were the parts that are proportional to one another, so x divided by 4. When we cross multiply, we have 80 is equal to 5x. Divide by 5 to both sides. X is equal to 16. So that means that this altitude is 16. Okay, now this is the median. It cuts the two parts in half. We still have corresponding sides. That means 9 still corresponds with 24. So 9 divided by 24 is equal to the medians, which is x divided by 15. I'll write it first and then this one. We cross multiply. We have 24x is equal to 135. We're going to divide both sides by 24. X is equal to 5.625. Alright, on this one is a little special. What I would do is make a little star. If you happen to have a highlighter, you're welcome to highlight it. I don't have one with me right now. Next time I'll hopefully get some highlighters out for you. But how this one works is that these are the sides that are proportional. It actually makes these two on the sides proportional. So you have this is proportional to this. So I'm going to circle it. This one is proportional to this. So we're going to write 8 divided by 6. The other parts that correspond are the bottom. So this side and this side are the ones that are proportional. How do we get this value? Well, I'm going to make up a value just to help you understand. Let's pretend, we're just pretending right now that this is 7. If that's 7, then I do 20 minus 7, which gives you 13, to have those two sides. So we're just pretending it actually won't work if it is that. But that's what we need to write. So since the 8 was the one that we wrote first, then we need this length right here. This length then in general is 20 minus x. Because if we subtract that x part, that's what's left of the 20. And that's your numerator. So 20 minus x. The denominator was the part with the 6, so with this bottom part that corresponds, making it x. We cross multiply. We have 8x is equal to 6 and open parentheses because it's the whole numerator we need to multiply by 20 minus x. 8x is equal to 120 minus 6x. I'm going to add 6x to both sides. That gives me 14x is equal to 120. Gonna divide both sides by 14. X is equal to let's check because this does it simplify. 120 divided by 14. Math, enter. Well, 67th. Could have written a decimal approximation, but that would give you the exact value. All right, for the next one, we're still doing the same thing. These are medians. Don't forget that vocabulary when it cuts it in half. This side corresponds with this one because of the angles, we can tell. So I have x minus 2 divided by 2x plus 3. And that's equal to, then these two are the ones that correspond with one another. 4 divided by 10. When we get to the test, make sure that you ask me. You can ask me, did I set it up correctly? But the algebra you should be okay with. So we have 10, open parentheses, x minus 2 is equal to 4. Don't forget the parentheses for all of the denominator. 2x plus 3. We have 10x minus 20 is equal to 8x plus 12. Gonna subtract 8x from both sides. I'm gonna go ahead and add 20 to both sides. And I'm gonna write it over here. 2x is equal to 32. Divide by 2 to both sides. x is equal to 16. All right, let's take a look at your homework. In the previous homework assignment, please make sure that you write the ratio like I asked. Show your work. You know how my class works. It still will be the same. I just want to make sure that you're okay with the pictures. So if a person that is 6 feet tall casts a shadow that is 9 feet long. So here's your person. Doo-doo. And here's their shadow. Doo-doo. We call this 6 and that's 9. We're still talking about triangles. Like this. And we have another one with the person that is 4.5. So look at that little piece. It's a Miss Hernandez size. Okay, and it casts a shadow, but we don't know how long the shadow is. Well, so what's 4 feet and 6 inches? Well, 4.5 would be easier for you to deal with. And then this is x. You set up your proportion and solve for x. Okay, so on this next one, it says Joe is 5 feet 6 inches tall. We can rewrite that number as 5.5 because 6 inches is half a foot. And casts a shadow of 14 feet long. Man, that's a long shadow. Okay, so we got our person. And then here's their shadow. So we're going to call that 5.5. And then this is 14. At the end of Joe's shadow is also the end of a building shadow. So what they're saying is that however the sun rises, it's going to eventually touch a peak of a building. And then this is the end of that shadow for that building. At the end of the shadow. If the building is 328 feet from Joe, so they're saying this distance right here. Okay, if the building is 328 feet from Joe, how tall is the building? So we don't know this measurement right here. And that is x. And then it says, hint, Joe is standing in the shadow of the building. What are they trying to tell us? You see the little triangle right here? That's going to be proportional to this triangle right here, making this whole length 328 plus the 14. Set up proportions, solve for x. Think everything else you would be okay with. Just make sure that if you have any questions as a class, if nobody knows how to do it or is not sure, please let me know so I can help you next time.